Hi everyone, today I'll be talking about the potential of cannabis-based medicines to treat psychiatric illness. So mine's more from a preclinical research point of view and focusing in on cannabidiol. So I'm a scientific affiliate of ACA, but I believe Rachel Galetis, who's our next speaker, will be talking about ACA. So I'm also a senior lecturer at the University of Wollongong. We've just completed building, as of January this year, of our new research institute, Molecular Horizons, and this is a purpose-built facility around some of the world's most powerful cryo-electron microscopes. And I've got my lab facility up there on the 3rd floor. So next door we have the Illawarra Health and Medical Research Institute, which houses clinical trials rooms as well as further lab facilities and links to the local health district. So the idea is that we can take our disease and treatment findings on a molecular level and transfer them right through to the clinic. So my research focuses on cognition. This includes multiple different aspects of brain functions such as processing speed, decision-making, learning and memory, and attention span. And the reason that I'm interested in cognition is because multiple different diseases of the brain, whether it's psychotic illnesses or depression and anxiety, degenerative disorders, and even substance abuse disorders, they all manifest in cognitive impairment, but medications aren't able to treat these deficits, the existing medications. Today I was asked to speak about schizophrenia. So some of you are clinicians, but schizophrenia is really complex. We know that it has 3 different symptom domains. So there's the positive symptoms that include all the heightened behaviours, so such as hallucinations and delusions. We then have negative symptoms, which is basically flattening of behaviours. So lack of speech, social withdrawal, lack of communication. And then there's the cognitive deficits. So again, distortions to decision-making processes and thought processing, as well as issues with learning and memory. The symptoms of schizophrenia were first reported by a clinician in the late 1800s, but to date we still don't have a prevention or effective treatments. Antipsychotic drugs are prescribed to treat some of these symptoms, but they can't treat all of the symptoms, particularly these negative and cognitive symptom domains. And they can cause some fairly serious side effects, such as cardiac issues, but also obesity, with some reports suggesting up to 15 kilos of weight gain within the first year, as well as type 2 diabetes. So there's certainly a need for new antipsychotic medications that can improve patient quality of life, which leads me to cannabis. So this was a book that was published in the 1970s by Ernest Abel, and he talks about the first 12,000 years of human interaction with the cannabis plant. And he makes mention of a Chinese emperor that was around 2900 BC. And the emperor had made reference to the word ma in the ancient texts. And turns out ma is the Chinese word for cannabis. And even back then, the emperor noted that ma was a very peculiar drug because it possessed the properties of both the yin and the yang, so the masculine and the feminine. And even to date, I think we can all agree that cannabis is highly complex, as is the endogenous cannabinoid system in the human body. We know, and other speakers have said it, that cannabis has a long history of being bad, particularly when it comes to brain health. So we know that it can cause cognitive deficits in some people. Work by Nadia Solowi here at the University of Wollongong has shown that it can actually reduce brain volume. But there's a high prevalence of cannabis use in people with schizophrenia. This can lead to worsened psychotic symptoms. It can cause medication non-compliance that can then lead to further relapse in psychosis and hospitalisation. But I suppose the question we've all been asking over the last few years is cannabis all bad? So we've conducted a number of reviews, including a systematic review that looked at all the knowledge around the effects of CBD and its benefits in cognition in a number of different neurological and psychiatric illnesses. We found that there was already early evidence that cannabidiol could treat the negative and positive symptoms of schizophrenia in patients, that it was a powerful anti-inflammatory agent that was protective of the brain. And we also found evidence that it could treat cognitive impairment in multiple different disease states. So in cannabis users that were experiencing cognitive impairment due to high THC levels. So some of these diseases are in preclinical studies, but also some of them are in clinical, such as Parkinson's disease and Huntington's disease. So you can see a long list there where cannabidiol was able to restore cognitive function in multiple different disease states that manifest cognitive impairment. But at the time, the question of whether cannabidiol could improve the cognitive deficits of schizophrenia hadn't been asked. So we set out to answer, or partly answer that question using a rodent model of schizophrenia called the Maternal Immune Activation Model. And the idea is that epidemiological evidence suggests that during the early stages of pregnancy, a maternal infection can disrupt fetal neurodevelopment, and it can increase the risk of the offspring developing neuropsychiatric disorders later on in life. And we can model this risk factor using a pretend virus called poly-IC. So basically we give pregnant rodents this poly-IC, and it causes an immune response that causes cytokines to cross the placenta and into the fetal brain. And what we find is that in the offspring, they start to develop structural and neurochemical changes in the brain that reflects what we see in postmortem schizophrenia. And they also show behavioural deficits that are similar to what we see in the clinical scenario. Importantly, these symptoms don't actually show until early adulthood in the rodents, which is important parallel to the clinical scenario where most psychotic episodes are occurring during that risk period of between 18 years to early 20s. So we took our schizophrenia model and we compared it to healthy controls, and we basically took the offspring of those rodents and we gave them either CBD or a vehicle control, and we treated the offspring from adolescence to early adulthood, which was that key developmental risk period, and we treated them for 3 weeks. And during this time we looked at different aspects of their learning and their memory, as well as social withdrawal. So that's the cognitive indicators of cognitive impairment, as well as an indicator of the negative symptoms of schizophrenia. And we also looked at their body weight, given that commercially available antipsychotics cause these weight gain side effects. And actually, if we give commercial antipsychotics such as olanzapine to rodents, they also start to put on weight and develop diabetes. So when we looked in the males, we found that, so this is our schizophrenia group, the males showed significant impairment in their recognition memory compared to the healthy controls. And when we gave them CBD, this was completely restored back to normal levels. Now, how do you know if a rat has a good recognition memory? Well, we capitalise on the idea that rats like to hang out with new stuff. They get very excited about new things. So we take building blocks and we stick the building blocks into the rodent's home cage overnight, and they're very excited to see these blocks and they hang out with them all night. But by the time the morning comes around, the blocks are old news. So when we stick the rodent then the following morning into an arena that it hasn't been in before, the rat will ignore the blocks and it will spend time exploring the arena. We then take the rat out, and when we put it back in again, there's a new object. So a rat with an intact recognition memory will hang out with this new object a lot more. We also conducted the T-maze test. So this is a bit more about learning and memory and decision making. So basically we stick the rat in the T-maze, we block off one of the arms of the T-maze, and we stick a chocolate reward in the end. And basically the rat will run down to the T-maze, it'll see that this wall is blocked, and it will run in and grab the chocolate reward. After a bit of training, we can actually teach the rats that if this was blocked off last time, well, next time when you go, this is the arm that's going to be open. So when you give the rat the choice, it'll run down here, and instead of running to where the reward was last time, it remembers that this arm was blocked, so the reward will be in this arm. So basically we saw a similar trend in working memory, where they showed a deficit in the schizophrenia group that was completely restored by cannabidiol. And in their social interaction as well, a same trend, a reduction in their social interaction that was completely restored by cannabidiol. And this was without the weight gain side effects that, as I mentioned before, we see with existing medications. When we looked at the females, there were some differences, which I think could potentially inform clinical trials that there are sex differences in the endogenous cannabinoid system, as well as sex differences in the inherent disease itself, such as depression and schizophrenia. So in the females, we saw a similar trend where there's a reduction in recognition memory that was restored by CBD, a reduction in social interaction that was restored by CBD. But what we also found was that when we gave CBD to healthy rats, it actually caused a negative effect on their social interaction. So if we think of cannabis and cannabidiol as a true medicine, we wouldn't give it to someone who wasn't sick. So it's actually causing deficits. We've been spending a fair bit of time trying to figure out how CBD works, which is one of the major benefits of actually working in preclinical modelling. We can get in and really explore the brain. And instead of showing a whole heap of graphs, I just thought I'd let you know that cannabidiol causes widespread changes in multiple different neurotransmitter systems in multiple different brain regions. We're also finding evidence that it impacts on neurogenesis in a positive way, so the creation of new neuronal connections that are fundamental to learning and memory. And this is in multiple regions, so the cingulate gyrus, the hippocampus, the amygdala, the prefrontal cortex, and the accumbens are the results that we've shown so far. So the conclusion of that study was that CBD does act as an antipsychotic drug. It can change brain signaling and does change behaviour. It can improve some of the symptoms that are resistant to existing medications, so those negative and cognitive symptom domains, without the weight gain side effects of existing medications. But there are some sex differences to consider, and our mechanistic studies are ongoing. So in the meantime, a group from Italy put out a review on the clinical studies that have been conducted looking at CBD around that time, and they found that 5 out of 8 clinical studies looking at multiple different illnesses that manifest psychosis, CBD was able to treat those psychotic symptoms. So in schizophrenia, in bipolar disorder, and in psychosis that was associated with Parkinson's disease. So since then, there's been some more clinical trials in schizophrenia, but all of the clinical trials over the years in schizophrenia have shown that CBD can improve psychotic symptoms. Only 2 of those trials have actually looked at cognitive function, but although there were improvements, these improvements reached a 0.068, a very frustrating p-value compared to the placebo. So I still think that the efficacy of CBD to improve psychotic symptoms is really important given the dried antipsychotic pipeline that we're facing at the moment. So the question that my lab is now asking is whether we can make it better. So can we make CBD better? And we have had some really exciting results come through on some of the other 600 or so, we haven't explored 600, but some of the other compounds that are in cannabis, including terpenes and non-cannabinoid molecules, thanks to funding from the Rebecca Cooper Foundation. So stay tuned for those results. So everybody, or lots of people, say that CBD is not psychoactive. So if we just look on dictionary.com, the definition of psychoactive is a substance having a profound or significant effect on mental processes. The World Health Organization says that psychoactive substances are those that when taken in or administered into one system affect mental processes such as cognition or affect, so mood and emotion. But you might be like trumping, you don't believe the World Health Organization, so let's see what Wikipedia says. Psychoactive drug is a chemical substance that changes brain function and results in alterations in perception, mood, cognition, behavior. So the fact that we're trying to use CBD as a treatment for illnesses of the brain inherently shows that CBD is exerting effects on the brain. It's able to hopefully restore imbalances in brain function that then have a resulting effect of positive effects on the behavior. So it may not be intoxicating, so to speak, but it is absolutely inherently psychoactive. So then luckily we're not putting it in smoothies or having it in our daily dose of our latte or using it as a replacement for Nutella. But in conclusion, CBD is a psychoactive drug. It does have beneficial effects as a medicine for psychiatric illness, certainly worthy of further investigation, and aptly in those doses a Schedule 4 medication, just like other antipsychotic and anti-anxiety medications are. So I'd like to acknowledge my lab group and my collaborators, as well as my funding and support. My contact details are there if you want to get a hold of me. And I just thought I'd put a slide in at the end just to show some of the things that we do in our lab. If anyone wants to collaborate, we're really open to collaboration. So thank you.